Hello, you smart cookies, and welcome to today's lesson in virtual math class. Today, we're going to be talking about comparing proportional relationships. And our objective for today is that students will be able to compare proportional relationships, building on what we've already learned this week. Okay, so the first thing that we need to know is the rate of change. So the rate of change in a linear relationship, that just means a straight line, is the amount y changes when x increases by 1. The rate of change in a linear relationship is also the slope of the graph. So the rate of change equals slope. They're the same thing. So you already know how to find the rate of change. So the rate of change, no, you already know how to find the slope, which means you already know how to find the rate of change. So in this graph, y increases by $15 whenever x increases by 1 hour. Therefore, the rate of change is 15. And we could easily pick out 2 points on our line, and we can see from 40 to 100 is 60. So our change in y, or a vertical distance, would be 60. And we go from 2 to 6 for our horizontal distance, and from 2 to 6 is 4. And so if I do 60 divided by 4, that gives me 15. So yeah, my slope and my rate of change are the same thing. So now let's talk about equations of proportional relationships. So if you see an equation like y equals 3.5x, the number with x is your slope. So the number with x is slope. So in this case, 3.5 is the number with x, so therefore 3.5 is the slope. And then y tells us our total. And x would be my, it's my variable, but that's like, if I see like per hour, per day, anything like that, that's what I would multiply. So if I had like rain falls at 3.5 inches per hour, so that per hour, or the hour, would be my x here. And then if I multiply 3.5 times however many hours, that would give me my total, which would be my y. So that's just equations really quick, and we'll look at some specific examples in just a minute. Okay, so I know there's a lot of words on this page, but don't freak out quite yet. So it says Elena and Jada both make money by helping out their neighbors. Elena babysits. Her earnings are given by the equation y equals 840x, where x represents how many hours she works and y represents how much money she earns. So Jada earns $7 per hour mowing her neighbor's lawns. So question number 1 says, who makes more money after working 12 hours? How much more do they make? So let's start with Elena. So if x represents the number of hours she works, it tells me that they work for 12 hours. So I'm going to write the equation by plugging in 12 for x, because x is the number of hours and she works for 12 hours. So I'm going to have y equals 840 multiplied by the number of hours, which is 12. So what is 840 times 12? 840 times 12 equals $100.80. So that is how much Elena is making. So Elena makes $100.80. So now let's look at Jada. If Jada earns $7 per hour and she's working for 12 hours, I can do 7 multiplied by 12. So the amount of money she makes per hour multiplied by the number of hours she works. And what is 7 times 12? 7 times 12 is 84. So who makes more, Jada or Elena? Elena makes more, because Elena makes $100.80 for 12 hours, and Jada only makes $84. So now, how much more does Elena make than Jada? So if I do $100.80 minus the $84, so again, that's $100.80 minus 84. So the amount Elena earns minus the amount that Jada earned, what is the difference between those? That would be $16.80. So Elena makes $16.80 more than Elena. So number 2 says, what is the rate of change for each situation and what does it mean? So the rate of change is per one. So in this case, we're talking about hours. So it's going to be the amount that they make per hour. So Elena makes $8.40 per hour, right? Because y equals 840x, where x is the number of hours. So the amount she would make would be $8.40. So $8.40 would be for Elena. And then for Jada, it just straight up tells us that she makes $7 an hour. So what does it mean? It means how much they make an hour. Per hour. So how long would it take each person to earn $150? Explain your reasoning. So if it tells me that the total is 150. So if I'm looking at Elena's equation, Elena says y represents the total or how much money she earns. So if y needs to equal 150 because that's how much she's earning, then I would have 150 equals 840 multiplied by x. Now I have an equation. Right now I'm multiplying 840 times x. So in order to solve for x, the number of hours, I'm going to divide both sides by 840. Now, what is 150 divided by 840? That equals 17.857, but in this case, I'm going to round that up to 18 because can you work 17.857 hours? Yes, but chances are that you're going to get paid for 18 hours if you work that. So I'm just going to round up and say about 18 hours. Now, I'm going to do the same thing for Jada. So Jada, she needs to earn $150. And then she earns $7 an hour. So 7 times some amount of hours, just like I did over there. So in this case, I'm multiplying 7 times x. So I'm going to divide both sides by 7. And what is 150 divided by 7? You should get like 21.42. But in this case, I'm also just going to round that up to 22 because if she worked for 21 hours, would she make $150? No, she wouldn't. So that concludes for this question. I know it was a lot, but no worries because we'll do another example. Okay, on this one, it says Han and Claire have summer jobs stuffing envelopes for 2 different companies. Han earns $15 for every 300 envelopes he finishes, and Claire's earnings are represented in the graph. So for 400 envelopes, she earns $40. For 900 envelopes, she earns $90. So question number 1 says, who would make more money after stuffing 1,500 envelopes? How much more money would they make? Question number 2, however, says, what is the rate of change for each situation and what does it mean? So I think the answering number 2 will help us answer question 1 better. So I'm going to start by answering question number 2. So what is the rate of change for each situation? Remember that the rate of change is per one. So in this case, I need to know how much money they're making per envelope. So for Han is making $15 per envelope. So if I take the amount of money he earns, 15, divided by the number of envelopes he's stuffing, that's going to tell me how much he's making per envelope. So what is 15 divided by 300? You should get 0.05. So the rate of change for Han is going to be 5 cents or 0.05. Now, for Claire, I'm going to do the same thing. So how much money she makes? First, she makes $40 per 400 envelopes. So same thing. So if I do 40 divided by 400, what do I get? You should get 10 cents or 0.10. So Claire's is 0.10. Now, if going back to number 1, who would make more money after stuffing 1,500 envelopes? How much more would they make? So Claire is making 10 cents per envelope. So if there are 1,500 envelopes and she's making 10 cents, I can multiply those together to figure out the total. So if I take 1,500 times 10 cents, that's going to give me $150, right? So now I'm going to do the same thing for Han. Han is making 5 cents. So it's still stuffing 1,500 envelopes, but he's only making 5 cents. So 0.05. So what do you get if you multiply 1,500 times 5 cents? 75. So if Han makes 75 and Claire makes 150, Claire is going to make more money, but how much more? So if you do 150 minus 75, what do you get? What's the difference there? You would get $75. So Claire makes $75 more. Now, who gets paid more for their job? So if Claire is making 10 cents per envelope and Han is making 5 cents per envelope, who's getting paid more? Claire is, because she's getting paid 10 cents, whereas Han is only making 5 cents. So Claire would get paid more for their job. And that concludes today's lesson. I know that this was kind of long, but that's why I only did 2 examples, but I couldn't narrow it down any more than that. So thank you for hanging in there. You guys are all a bunch of geniuses, and I'm so proud of the work that you're doing. Keep up the great work, and I look forward to everything that you are going to accomplish.